All right, so I've heard some questions about how conservation of energy works, and I wanted to record something to help show that for a couple specific examples. So here's one of them. And I'll do another one where it's going up the hill, but it's all basically the same concept. Okay. So what we do is we try to break the problem apart into its pieces. Always, 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 always. What do we have in terms of pieces? If we look at our conservation of energy, we have four pieces that matter: v initial, height initial, final velocity, and height final. Those are the four pieces that matter. So it's a matter of finding out who these pieces are. Who these pieces are that matters. And the reason I'm not saying that mass matters always forever, right? Except for in this equation where they cancel out in every term. So what we can do is we can cancel it out if we want. Now, another thing we can do is you might say G does, it matters. You're right, it does. It's just we don't have to find G. We don't have to look for it. We know it. We know what gravity is. We've seen gravity a million times now. So the things we need to look for in our problem are the initial speed, the final speed, the initial height, and the final height. So let's do that over here for this little cat in a sled at the top of the hill. The cat starts at a hill that has a height of 20 meters and it ends up at the bottom of the hill. What is the final speed of the cat? That's what we're looking for. So if we look over at our conservation of energy equation again, our initial speed right here, we don't know what it is, do we? Well, if we're starting at the top of a hill, usually when you do that on a sled, you start off not moving, right? So your initial speed equals 0. Now next, height initial. Who is that? Well, height initial in this case is whatever the height of the hill is, so 20. So 20 meters. Next, we have final speed at the bottom of the hill. Vf equals question mark. That's what we're looking for. And then finally, height final. What is the height above the ground of the ground at the bottom of the hill? Well, I'm assuming that this is the bottom. So if it's the bottom, that means its final height is nothing, 0. So now it's just a matter of rewriting this equation with the stuff in it, okay? So let's write it with the stuff. Also, the mass of the cat once again cancels, so we don't need to know what the mass of the cat is. Mass of the cat could be 1,000 kilograms. The mass of the cat could be 5 kilograms. It doesn't matter when it comes to what we're looking for here. The mass only matters when you're looking at the pure energy of the situation. Okay, so now let's do the thing. 1/2 times V initial squared, we're going to rewrite it real quick, plus GHO equals 1/2 times V final squared plus GHF. So now we plug in our numbers. V initial is 0. That cancels this entire term because anything times 0 is 0. Height initial is 20, so G 9.81 meters per second squared times height initial, which is 20 meters, equals 1/2 times Vf squared. We do not know what the final speed is, so we'll just write it out like that. Next thing you're going to do is you're going to have GHF. And this right here, HF, is equal to 0. So if HF is equal to 0, that means that this whole term equals 0. So we're left with just this part. You'll notice that it goes from being very, very long-winded to being a lot more easy to work with, right? So what we're going to do is we are going to go ahead and find the answers to these various things. So 9.81, we bring our calculator into frame. 9.81 times 20 should give us 196.2. Okay, there it is. So 196.2 meters squared per second squared equals 1/2 times Vf squared. Multiply both sides by twice by the number 2. And bring our little calculator back into frame, times 2 gives us 392.4. 392.4 meters squared per second squared equals Vf squared. We take the square root of both sides and we find that the answer is about 19.81 meters per second. Vf equals 19.81 meters per second. All right? So once again, how we did this was we looked at our problem. We looked at the pieces. We needed 4 pieces to make this work. We needed initial speed. How fast is it going at the top of the hill? We needed initial height. What is the height of the hill? We needed final speed, which is what we were looking for. So that's our x, our variable that we're looking for. And we needed height at the bottom of the hill. And height at the bottom of a hill is 0. So those were our 4 important pieces that we found there. Remembering, of course, that g is important, but we know it, 9.81 meters per second squared. And the mass doesn't matter because it cancels. Okay, so once again, for going down a hill, all you need to do is look for those 4 pieces, plug them into the equation, look for what you don't have, and you will find your answer.